Hey everyone, and welcome back to the channel. Today we're going to tackle a topic that's a little intimidating, could be a little intimidating for you. It's about balancing chemical reactions. Let's get started. First, let's understand what a chemical equation is. It's simply a symbolic representation of a chemical reaction. We've got our reactants on the left, the substances that react, and our products on the right, the substances that are formed. So now, why do we need to balance them? Well, it's all about the law of conservation of mass. The law states that matter cannot be created or destroyed in a chemical reaction. So the number of atoms of each element must be the same on both sides of the equation. So what that means is if you count all the specific atoms on this side, that should equal all the atoms on this side. And if it's not balanced, it's like saying you put 5 ingredients into a cake and somehow ended up at 10. It just doesn't make sense. Okay, so let's break down the balancing process into a few simple steps. We'll use this example out here. So if you kind of take a look at this example, you'll see if we just do an atom count on the left and the right, so let's start with the left. We have 1 carbon, we have 4 hydrogen atoms, and we have 2 oxygen atoms. All right. And on the right, we have 1 carbon, we have 2 hydrogens, and we actually have 3 oxygens, 2 out here and 1 out here. Okay, so clearly the atoms are not balanced. We need to balance this. So in order to balance it, just start from the top. Okay, so the carbons are balanced on both sides, so we don't have to worry about those. The hydrogens, on the other hand, are not balanced. We have 2 on the right and we have 4 on the left. So in order to balance the hydrogens on the right, all you have to do is multiply this 2 with 2. And here is something important we need to mention. You will always multiply the atoms. No addition, no subtraction, no division, only multiplication. And you will always, rather you should always multiply the atom that is that has the fewer number of atoms. So basically multiply the side that has the fewer number of atoms. In this case, the right side has a fewer number of hydrogen atoms. So we'll multiply that with the 2, okay? And once we multiply that with the 2, this 2 is going to go up and place itself out here beside the atom we were trying to balance. Okay, now notice carefully, the 2 that goes up here goes up as a coefficient, okay, not as a subscript, which is this, not as a superscript. It goes as a coefficient, okay, and it always goes in to the left of the molecule. So in this case, that's the water molecule. It goes to the left of that molecule. So now, as a result of this 2 going up here, now you have 2 times 2, so that's 4, and you get the same result by looking at 2 times 2 out here at the bottom. So now we have a total of 4 hydrogen atoms for that molecule. But as a result of balancing the hydrogens, what happened is this 2 also applies to the oxygen in this molecule. So we have to do a recount for the oxygens. So now we have 2 out here and then 2 out there. So therefore, the new number of oxygens is not 3, rather 4. And now at this point in time, let's go ahead and balance the oxygens. So as you can see, on the left we have 2, on the right we have 4. And as I mentioned previously, you want to multiply the one with the fewer number of oxygens with a factor that's going to make it equal to the one with the greater number of oxygens. So I'm going to multiply this with 2, and that 2 goes up and you can place it out here on the left. And that makes the total equal to 4 oxygens. So now if you do a visual inspection of this, you have 1 carbon on both sides, 4 hydrogens on both sides, and 4 oxygens on both sides. If you look at the equation, they should also visually align. 1 carbon on both sides, 4 hydrogens on the left, 4 hydrogens on the right, 4 oxygens on the left. Notice carefully, 4 meaning 2 times 2, and 4 oxygens on the right, which is this 2, and then 2 oxygens from there. Now let's go ahead and balance another equation to get some practice. So out here we have aluminum plus hydrochloric acid, or HCl, gives you AlCl3 plus H2. So the first thing you want to do is you want to count the atoms on the left. So that's what we'll do. We'll start with aluminum. We have 1 aluminum, we have 1 hydrogen, and we have 1 chlorine. And then we'll count the atoms on the right. We have 1 aluminum, we have 2 hydrogens from these two, and then we have 3 chlorines. There you have it. Now, we're just going to go from the top to the bottom to balance this. So the aluminums are already balanced. The hydrogens are not. So we're going to multiply the hydrogen on the left with a 2 to get it equal to the hydrogen on the right. And then this 2 is going to go up here to the left of the HCl. And then that's going to equal a net of 2. Now notice carefully, when we did that, the chlorines are going to change because of the 2 out here. So therefore, the new number of chlorines on the left is 2. Okay, so once we have that 2 out there on the left, now all you're going to do is you're going to try to multiply this 2 with a factor that's going to make that equal to 3. Okay, so what I would recommend is you multiply it with a 1.5 to make that equal to 3. Okay, so this 1.5 is going to go up here and it's going to get multiplied with the 2. So out here on top, it's going to be, I'll just rewrite this a little differently. If you take 2 times 1.5, you get 3 HCl. Okay, so once we have 3 HCl, now the next thing to look for is, notice carefully how the hydrogens changed. Okay, and I want to just take a pause out here and tell you, don't worry about multiplying it with a decimal number right now, because you might be thinking that, all right, atoms are whole, you can't have half an atom essentially, but this is just a mathematical manipulation. Okay, so what we're going to do is later on we're going to get rid of the decimals. Okay, so don't worry about that right now. So once we have the 3 out here, the hydrogens changed. So the new number of hydrogen out here is going to be 3. And then we're going to now rebalance the hydrogens on the right out here by multiplying that with 1.5. And once we do that, then this 1.5 goes up there. Okay, so then that becomes 1.5 to give you a net of 3 hydrogens. So now at this point in time, if you just take a look, you have 1 aluminum on both sides. We have 3 hydrogens on the left, 3 on the right. Okay, and we have 3 chlorines on the left and 3 chlorines on the right. At this point in time, to get rid of the decimal, all you have to do is multiply the whole equation by a factor that's going to get rid of the decimal. In this case, we're going to choose 2 because 2 times 1.5 gives us 3. And you want to choose the lowest factor. Okay, so that's going to give us a complete balanced equation, which is going to be 2Al plus 6HCl gives us 2AlCl3 plus 3H2. Now let's visually check to make sure that all the atoms on the left are equal to all the atoms on the right. So we have 2 aluminums on the left, 2 on the right. We have 6 hydrogens on the left, 6 on the right. We have 6 chlorines on the left, and 2 times 3 is 6 chlorines on the right. And there you have it. That's a complete balanced equation for you. So now we've done 2 examples. I'm going to give you another example, and I want you to pause the video and try it yourself. And then you can leave your answer in the comments, and I'll be checking out what you wrote and advise you accordingly. I hope this video has made balancing chemical reactions a little less daunting. If you like this video, please don't forget to subscribe, like the channel, share with your friends, do all the good stuff. And I can't wait to see you in the next video.